All right, I'd like to go ahead and do a problem similar to the last one on your Module 9 similarity assessment. So the first question asks you to complete the table. So you can see that this table is already completed for this specific function, but I wanted to go ahead and show you how you could complete it if, say, for instance, we didn't have this value of 4. So we take our equation, y equals 3x plus 1 over x squared, and we plug in our x value here of 1. So 3 times 1 plus 1 over 1 squared gives us 3 plus 1, which is 4. So that's how you can fill in those missing values. So here, if I were to plug in 3 for this equation, I would get 9.11 repeating as my value for y. So the second question is asking you to graph it without a calculator. So what I'd like to do first is use a calculator just to see the basic shape of this graph. So if we look at the basic shape, so I plug that into y equals, we kind of have a nice little swoop going up here and then a little curve going down here. So it's an interesting little graph. So now you have kind of a basic idea. Let's go ahead and do what the question asks and graph that by hand. So I actually need to move this up a little bit because we need to be able to, let's just go right about there. Okay, so let's just plot some points. All right, we have -3, 1, 2, 3, and -8.89. So 9 would be there, so roughly right about there. -2 and 5.75. So right about there. -1, -2. We have an error at 0. The reason we have an error, if you look here, 3x plus 1 over x squared, anytime you have a 0 in your denominator, that's going to be an undefined value. So that's why we do not have a point at 0, and that's why you would get an error if you tried to plug it in. All right, over 1 up 4, 1, 2, 3, 4. Over 2 up 6.25. Over 3 up 9. And a little bit more than 9. So that's kind of giving us our basic shape. So if we went ahead and plugged in a few more values, so you can see that here we have a point of discontinuity close to 0. So that shouldn't be touching, but it's kind of close. So let's say we plugged in, I don't know, say 0.5, just to get one more point there. And we can change the scale a little bit. So I'm going to change the scale to 0.25 and then hit second table. So we can see at, so on the TI-84, I don't know if you're familiar with that or not, on the TI-84 you can plug in your equation to y equals. You could do this on a Desmos grapher as well, and then check that table to see those corresponding values. So when we plug in, let's say, I'm going to just scroll down, get to some positive table values here. So when we plug in it's going to keep going. So when we plug in 0.25, we get 16.75. So 0.25 is going to give us a point up here. I'm not actually going to count to 16, but we're just going to pretend that it's over here. So that's what's giving this graph the rest of this shape. So we kind of needed a few values in between 0 and 1 to really see that, which you do have on the actual assessment. So that's the basic shape. So this question is saying write down the largest value of k so that the equation has exactly one solution. So the question is asking us, when does 3x over 1 divided by x squared equal k have only one solution? So equals k, where k is a constant. So the way you can solve this, when you have two equations on each side of your equal sign here, you could graph this by itself, which we did already, y equals 3x plus 1 over x squared, but we could also graph y equals k and see where these two graphs would intersect with one another. So if I were to draw a y equals k line at, say, y equals, let's say 1, 2, 3, 4, 5. So if I were to draw a line at y equals 5, where k is 5, you can see that is intersecting in 1, 2, 3 places. So that's actually giving us 3 solutions. We want to know where we would have exactly one solution. So the largest value of k, so that you have exactly one solution. So in this particular graph and equation, it's not going to be a nice pretty integer. It would actually be a decimal. But I know on the assessment it is an integer. So if you look at this point right here, this lowest point on this little curve, you can see if it goes through at that point, it still has 2 solutions. So it would be the next integer below that, if you're looking just for integers, where it has exactly one solution. So this value of k would give us just one solution, which would be 1, 2, 3. So in this case, it would be when k is equal to 3. So if we were to graph 3x plus 1 over x squared is equal to 3, we would only have one solution to that, meaning that this line y equals 3 would only intersect this graph at one place. So let's go ahead and look back at our TI-84 and let's graph that. So if we go to y equals, we have our original function in, and let's go ahead and put in y equals 3, hit graph, and when we graph that, we can see that it only passes through at exactly one solution. But let's see what happens when we plug in y equals 4. So y equals 4, that's the next integer up. Hit graph. So you see at y equals 4, it's going through 1, 2, 3. So that would give us 3 solutions to that equation. So you were looking for that first value that only gives you one solution. Okay, so the last question, and I'm going to go ahead and erase a little bit of stuff here. Oh, whoops, not the last question. Second to the last. So second to the last question is asking you to find all 3 solutions by drawing this value, 9 minus 3x. Need a little bit more space here. By drawing 9 minus 3x on this same grid. So again, I think I want to erase just a little bit more so it's cleaner. Quite a few marks going on there. So I'm going to go ahead and plot this graph for 9 minus 3x. So 9 is my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to plot a point at 9. And then my slope is negative 3. So I'm going to rise negative 3, 1, 2, 3, and run 1. So then I'm going to just go 1, 2, 3, run 1 so I can get one more point. So I'm going to draw a line there. So this is the line 9 minus 3x. So the question is saying state the approximate value of all three solutions. So that would be this point here where it's intersecting our curve, and this point here. So again, just to get an approximation, 9 minus 3x, you could go ahead and graph that here. I know it says to do it by hand, so you should definitely do it by hand, but this gives you an idea of what that graph looks like. So if we hit graph, you can see this is our line 9 minus 3x, and it's intersecting in 1, 2, 3 places. So you would look on your grid and see approximately where those points are, those points of intersection. Now, if you were allowed to use a calculator for this portion, you could use Desmos or a TI-84 and calculate exactly those points of intersection. But it's just asking you for an approximate value. Now, you could solve this algebraically, but the question states draw a straight line to solve this. All right, so now we're on to the last part. It says show how this can be written in the form ax cubed plus bx squared plus cx plus 1, where a, b, and c are integers. So at this point, and I'm going to go ahead and erase this. So at this point we have 3x plus 1 over x squared equals 9 minus 3x. So we want to do two things. We want to get all of our values on one side of our equation. We also don't want to have any fractions here. So notice this is a cubic that they're referring to, and we don't have a cubic. We do have an x squared in the denominator. So what we can do is multiply the entire equation by x squared. So 3x squared times x squared is 3x cubed. X squared times 1 over x squared is just 1. Because when we multiply this by x squared, we have an x to the power of 1 times x to the power of 2, which is x cubed. But when I multiply this term by x squared, my x squared is actually reduced to 1, so I just have a 1 here. And then we have 9 times x squared minus x squared times 3x, so minus 3x cubed. So I'm going to go ahead and get everything on one side now. So I'm going to add 3x cubed to both sides, which is going to give me 6x cubed, because these are like terms. I'm going to subtract 9x squared from both sides. And I already have a plus 1 on this side. And there we have it. A would be 6, B would be -9, and in this case our C value, since we do not have a linear term, would be 0.